Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analysts podcast. Each week, we discuss our latest data research and a topic related to app development and back-end services. My co-host for the show is Donnie Berkholz of 451 Research. Now let's get to the show. Hey, Alex Williams here of the New Stack, here for the New Stack Analyst Show. Today here with Donnie Berkholz, my co-host for the show. Hey, Donnie.
Howdy.
Hey. And Florian Leibert, founder of Mesosphere. Good to see you.
Hi. Great to be here.
Yeah, thanks for joining us. So we were just talking about what we're going to talk about. And my interests are pretty broad-based in terms of writing kind of, we're looking at kind of, these broader stories about really what's happening now in the market. And there was also a lot of events this week, I think relate to that. There was, you guys went, Mesosphere now is in general availability. You open up your community edition. And then there was also, Donnie was talking about, there's other things going on that he's interested in, was, related to like how Mesosphere is being used. But also there was the Hadoop Summit this week, and we thought we'd talk a little bit about that. So I thought maybe I could just, lead it off with my own question is like, I was talking with the Rancher folks earlier this week, right? They just got some new funding. And Sheng was talking a lot about how we're still not seeing this transformation to this app-based infrastructure. Obviously we're still very early in the process, but his point is that Docker's done a great job of like making, with the UI and making it accessible, right? And the ability to, just made it something enjoyable for, for the developer. But his point was like, but the infrastructure, there seems to be this need for this purpose-built infrastructure for these new kinds of environments. And so that's really my question, what is needed, what's at, what are the progress points, what are the dynamics here? So maybe Florian, if you can give us some of your insights into that.
Yeah, for sure. I mean, as you mentioned, like we had some news this week. Shameless plug here. We launched into GA. We launched the Datacenter operating system finally into GA. It's right now available on Amazon. And I hadn't heard before the term purpose-built infrastructure, but I think it's actually a really interesting term. So what we view as some of the key components of that are things in the realm of big data, continuous integration, continuous delivery, NoSQL or SQL, basically all the stateful applications, and then of course other infrastructure that's really essential, like Kafka, and which is a message queue. Mm-hmm. And I think there are really like a lot of pieces in the stack. But the other thing that we're of course seeing now is that a lot of these processes get packaged into a container. You ship them across, and you're starting to integrate integrate across all of these different silos, or what used to be silos, and you're building really like a converged infrastructure, if you will.
Yeah, it's a different kind of converged infrastructure, though. I mean, the converged infrastructure that you used to hear about was like for gigantic monolithic applications, right? Things from Oracle and SAPs and stuff. Exactly.
And now we are actually using all of these. They are really microservices themselves, right? That you're integrating with one another. And for us, that was a real big opportunity when we launched DCOS to showcase that you can start a marathon at Jenkins. So marathon is our take on a pass at Jenkins, which you use for continuous integration, and then you tie them together for continuous delivery. And on the same cluster, you can actually run your Spark jobs, your Hadoop jobs, and your NoSQL services like your Cassandra, or even things like MySQL, which we brought to not we, actually Twitter brought to Mesos, but we're collaborating with them on that. And you run them all on a shared environment, and you get to essentially solve the provisioning problem doing so. You can give each of these services a different priority. Then they can self-recover in case there's an outage in your data center. And on top of that, of course, it makes it much easier to set up this pretty complex system.
Yeah. Donnie, that complex system is something you talk a lot about. What questions do you have about this kind of, for Florian? I'm curious, what are some of the questions you have for him about this new kind of infrastructure that we see emerging, this converged infrastructure that he's talking about?
Yeah, it's funny because, I don't know, probably 15 years ago, I used to do high performance computing stuff. And the sense I get looking at what's happening here is that we're just kind of reinventing all of that for a different user base. Instead of for scientists written in Fortran, we're doing the same thing, for app developers and for data engineers, written in whatever the new languages of the day. So if you look at, I don't know, HPC back in the day, we had schedulers like Torque, like OpenPBS, like Condor, and a lot of it feels the same to me here happening all over again, right? You sort of started out with a very basic scheduler. You had sort of MapReduce, very locked in, then you had Yarn, and now you've got Mesos, where you can be flexible, you can have long-term jobs next to short-term jobs. And I'm kind of curious, was that an influence on your development of Mesos, or is that sort of an independent rediscovery on your part?
So, maybe it helps if I give you a little bit of background how I actually got drawn to Mesos and how we started using it.
Great, yeah.
At some of the companies I used to work at. So I discovered Mesos, which was called actually Nexus back in the day. It was was developed over at UC Berkeley, what's now known as the AMP Lab. And one of my close friends, actually, that I've known for 13 years, was working on that very project. And at Twitter back then, we had this big scaling problem, right? We were growing the user base quite quickly, and we had a Ruby on Rails application, which was great for prototyping and was great for velocity, but which wasn't really great for scale. So we did what a lot of companies do. We took that application, tore it apart, and created small microservices, connected them back into Rails. So Rails in the end was only a router, and these microservices needed to be deployed, and that was a big problem because you had the DevOps team as the bottleneck. They needed to, after you were done writing your service, you did your load testing, you figured out how many machines do you actually need. So you order the machines, and they of course don't come in overnight. If you're running your own data center, you need to. It takes weeks. Then you need to burn them in, which takes another couple of weeks. Then you need to go back and forth with your configuration files, be it Chef, Puppet, Ansible, Salt, whatever you're using for configuration. And 3 months can go by, and you have written software 3 months ago, and now it takes you so long to get it out there. And so that was our big problem. And when I talked to Benjamin Hintman, who was one of the co-creators of Mesos over at UC Berkeley, he said, well, you guys should take a look at what we are building. And we took a look, and we liked it a lot, especially the folks coming that came from Google to Twitter were used to a system they called Borg, and they got super excited. They're like, oh wow, finally we have this convenient infrastructure back that allows us to essentially write applications against the data center, treating the data center like one big machine, and B, being able to just to deploy our existing applications in a much more autonomous way. And that ended up being the direction that Twitter chose. And we back then really bet the ranch on a technology that now powers all of Twitter.com. I moved over to Airbnb, where I continued working on this project back then. Now we've productized it. But at Airbnb, we actually used it not initially for a pass, which was the Twitter use case, right? Microservices, rolling out microservices via Apache Aurora. But what we did at Airbnb is we chose big data, because that was the team that I was building out at the time as the use case for the Apache Mesos project. And so we built a system called Kronos, because you oftentimes run into this problem, right? You have one central cron host that's responsible for dealing with all of your ETL. So you're basically exporting a database into some sort of a text file then maybe uploading it into HDFS. You run some transformations on there, and then you have to load it back up into a database so it's more consumable. And it's actually a really fragile process if you control that by a cron, because if you have a network interruption, which happens on Amazon, since you don't have dedicated hardware more often than not. And of course, if you have also a single cron file, you run into the problem that multiple people might be editing it at the same time. It's just not very good for collaboration. And so we saw the opportunity of creating a new system that we named Kronos, which was a distributed, fault-tolerant cron-like scheduler that also supported dependencies and retries and things that you really want in a modern ETL pipeline. And I had this aha moment after actually writing the software, where I looked at the code and I'm like, wow, we just wrote, there was barely 2,000 lines of code back then, but we just wrote a distributed system that has no single line of networking code. And that was kind of like, whoa, there will be many more distributed systems out there in the future. And if Mesos makes it that easy, that's really that's a really revolutionary technology. And that's really how our company was born. But looking back at the research that was early done on Mesos, they were actually looking at systems like Torque and MPI, and I mean these more HPC these systems that were more used within the HPC community. I mean, none of the stuff that we do in computer science is truly new ever, is what I feel like. I mean, MapReduce was not invented by Google. It existed before, but I think as we have certain use cases and like big data processing, right, came up, and as we have these new use cases, old technology can be recycled in order to solve big problems.
Yeah, I was listening. Go ahead, Donnie.
Something that I'm really curious about with the way people are building apps that run on Mesos is, one of the issues with HPC, I'm just going to keep drawing the analogy because I'm trying to understand how things are changing over time, is, you've got, in some cases, you've got these apps called embarrassingly parallelizable, right? Yep. Where you basically split up a job, farm it out, and then, reduce it all down when you're done. There's not really a lot of internode communication during the job. And I'm trying to understand, the flip side of that is job types that require a lot of communication during the workload, right? Where, for example, if you're doing like a three-dimensional simulation, there's a lot of overlaps between the cubes and you have to keep sort of remapping and rebalancing everything. Is that something that Mesos works for right now or is good at? I'm sure you could make it work, but is that something that Mesos is good at, or should you keep using it for jobs that are really easy to split up?
So I think the answer to that is so first of all, Mesos is a general purpose scheduler. So unlike something like Yarn, which was really built towards just batch workloads, Mesos was built to handle pretty much all the use cases. And the key here is that Mesos provides you some base primitives that you will need in order to build a distributed system. And those base primitives are, for example, isolation, for which we now can use Docker, for which before Docker was around, we just used plain C groups, which is something built into the Linux kernel, actually largely contributed to by Google. So you have an isolation mechanism. You have a mechanism to send messages across all of the hosts that partake in your cluster, and you have things like an abstraction for state, so that you can store your working set in memory. And so one of the interesting things is if you look at some of the Mesos frameworks that were built early on, one of the things that comes to mind right away is Spark. So Spark, of course, it kind of falls into the category of it's easy to parallelize it, because it's especially initially the use case was to just show, I think, how you could rewrite MapReduce on top of Mesos. But there are other systems now that we're building that are more partitioned, and I think that's maybe the more what you're asking, like a Cassandra. So Cassandra is really partitioned, and it's a partitioned and replicated distributed system. And what does that mean? Well, it means you have the replication because you want to be highly available, and the partitioning in order to in order to allow, for example, for a much larger key space that allows you to access data. And with Cassandra, for example, initially you would think, well, maybe it's not such a great use case, because you with Cassandra you probably don't want churn, because churn will saturate your network. So if you have boxes coming and going, that'll mess with your network quite a bit. But if you think about it, you would run Cassandra in the cloud, and Mesos just gives you basically a new way of, if you don't use certain aspects of it, it gives you a new way of provisioning essentially a big computer, and you run Cassandra on it, and a lot of these parts will be static on top of your Mesos cluster. So your Cassandras will be static, but what can happen is you still have an outage. You can still have a rack going away or a switch failing. And if that happens, you have two options. You either solve this problem manually, meaning you get a pager alert as an engineer in the middle of the night, or then you undertake you try to start a new box, you create a configuration file, figure out how to quickly get that thing back online, or you rely on something that's automated. And I think this automation is what you can leverage Mesos for. So in that case, what we basically do is, like, we just say, if the Cassandra and Mesos cluster has an outage, well, restart that partition that went missing somewhere else. And so I think it's very widely usable, and that's really one of the reasons why we're such big fans of the project. It's not just for one use case. It's really also for any sort of distributed system that you want to build. You can leverage Mesos to get the job done much quicker or much quicker and with much less effort than if you were to just use plain sockets, if you will.
So you're talking about, like that, the manual notifications and the automated systems for notifications and such, and what you're seeing a lot from, like, the monitoring type of companies out there that are emerging, right? The Signal FXs of the world and everything else. Is there an intersection there with what you're doing and they're doing? Is there kind of overlap? This is where I think it starts to get pretty complicated for people, because there's, like, especially when you start to get into the discussions about orchestration, it's like, well, what is this thing? And, and how does it relate to the other pieces?
So I think overlap. I think, but for the overlap question, there's always going to be some overlap between companies, I think, that build software that's more generic. But for us, for example, we're not building things that would replace Splunk or anything like that. In fact, Splunk is one of the companies, for example, that's oftentimes used in conjunction with Apache Mesos and DCOS. What we are really focused on is we are focused on creating a system that allows you to get all of your infrastructure up and running as quickly as possible, so that if you're a small startup, a mid-sized company, or a large company, you don't have to ever worry about re-platforming again. You don't have to worry about throwing away what you had built. You can, from day one, effortlessly develop on a NoSQL database, maybe add a message queue to the mix, have your CI/CD set up from the get-go on top of Marathon or Apache Aurora or HubSpot Singularity, which are all Mesos frameworks. And we just want to make it ridiculously simple to build really complex systems and systems that actually solve a really hard problem, which is and make that scalable from day one.
So Donnie, but you talk a lot about the complexities that are, that have arisen, with these new distributed systems and these microservices environments. What Florian is saying is that there's a simplicity here that comes. Maybe not, simplicity is not the best word to use, but there's a different way of doing it, so it can be automated to some degree. Where's the complexity coming in for companies?
Yeah, I mean, I think Full, you're making a great point in terms of, Mesos providing basically a framework for building the services in the first place, right? Which eliminates a lot of the complexity as people don't know where to get started. Much like Netflix has done for running reliable services in the cloud. And I guess, once you've built it, the next question that comes up ties into what Alex was just talking about, which is, all right, how do you debug it? Because I'm not sure that gets any easier once you've had a nice framework to build it with.
Yeah, so I think that's actually a great question. So one of the nice pieces about and that's, I think, where actually containers come in really handy. And so one of the nice parts about the Mesos way of building systems is that you're decomposing a problem into tasks, and a set of tasks belong to what we call an application. Like a Kafka, for example, has a set of tasks, and these tasks may or may not run on different machines. But what you now have is you can essentially click on Kafka, and you can click on one of the tasks where you saw some anomalies and explore the log output of that task without ever having to SSH to that machine. And of course, what you now would do if you integrated that with something like Splunk, again, you can take certain actions basically just based on the task name. And so I actually think it makes it a bit easier once you take advantage of all the tooling that has been built around these systems. Because if you think about it, right, like a company like Twitter that has tens of thousands of servers, if something went wrong and they were just running VMs, and they just saw on a high level, something went wrong with this Kafka service, and it wasn't running on Mesos, it just was running on plain VMs. You could see someone actually logging into a set of hosts via SSH, browsing through the log files there until that person finds something. And this was actually what I used to do at Twitter before we were running everything on Mesos. And now in this new world with Mesos, you literally go to a web UI. You're like, wow, this task has some failures. Click on it, and you get the last lines of the log file outputted, and you don't have to SSH at all. And I think it really depends on a lot of the tooling. And of course, when you're going towards a new stack, you will likely require new tools that are really built for that stack and for that way of doing things. And that's one of the things that we are really focused on here at Mesosphere. We're trying to make it easier to debug large-scale distributed systems and in complex environments.
So what are those new tools that you see emerging to, to solve these emerging problems that come out of, building out these, operating systems that you're developing?
So I think one of them I mentioned briefly earlier, but the idea that you all of a sudden get to a self-healing environment is a big part of our mission. So, and I outlined this with Cassandra earlier. You basically have a node going down, and as long as you have some capacity available in your data center or cloud, you can automatically have Cassandra restart the process elsewhere. And that's actually really powerful because it actually cuts out the need to have a human involved in the process. Similarly, imagine you have 20 instances of a Ruby on Rails application up and running in your cloud environment, and one of the servers goes down. So this was a scenario that I saw at Airbnb a bunch. And again, you'd get a pager alert because we have 20 nodes for a reason. And especially maybe you'd have a whole region inside AWS going dark. You'd have to manually start up new virtual machines, which takes lead time, and then run Chef, Puppet, or Ansible in order to get them set up. Maybe you have a pre-baked image, but you have to do manual work. You have to make a lot of decisions. And I can tell you, like in the middle of the night when you wake up at 3 a.m., that's no tooling will prevent mistakes there. And I think a lot of it has to do with solving and preventing the need to debug with automation. And then, of course, oftentimes you do have to still debug certain things, and like that's much easier if you can actually start up a Kafka service without having to spend 3 weeks trying to configure it in your cluster and redirecting certain events into your Kafka message queue and so forth. So that's really one of the big motivators for us building DCOS, was to allow you to build a custom infrastructure with all of the tooling that you need, and you can wire them all together in a way that makes sense for you in your use case.
Which, Donnie, I think gets back to this issue of complexity that you're talking about too, because now you have a density issue, for instance, with containers, right? You now have these complex microservices environments. You need to have that self-healing capability, right? Which gets into a lot of like, how do the machines communicate with each other, right? And what is that, what is the messaging system that you develop for that? What is the languages that what do we know that these machines are communicating in? Is that part of what the complexity is, or is it something more, something different?
No, I mean, that's a big part of it, right? I mean, because, we've got the debugging and the tooling that we just talked about, but I think, if you just sort of walk through like the different tools we have already discussed today, and like, oh, well, here's what your architecture looks like. You take like these 75 things and then you build your microservices. There's a big challenge in terms of the learning process, regardless of how many frameworks are involved.
Oh, absolutely. And,
yeah. There's also a big challenge in terms of like, well, this works great for a Twitter with 10,000 servers. How far down can you scale that kind of thing? How far down is it reasonable to scale that kind of thing? Or do you go back to sort of, Martin Fowler's like, well, monolith first and then migrate to microservices if you really have to at some point, but don't start there. And I think that's something that a lot of people are battling right now, is where do you start and where do you make that change? Because there is a lot of complexity inherent in it.
Mm-hmm.
Yeah, I think to chime in here a little bit, I think initially like the complexity might look really overwhelming, but I think if you make it easier to set up some of these pieces of infrastructure, and in fact, it's interesting if you take DCOS, the latest version for Spin, what will happen is we have an interactive tutorial on there that will pop up that allows you to essentially start this Twitter clone. Within like 15 minutes, you get an application that's actually backed by Cassandra. So Twitter originally was backed by MySQL, and they moved some parts to Cassandra. But this application is right from the get-go backed by Cassandra, and you can scale it up to 20 instances, scale it back down, and the fact that this can scale to really thousands or tens of thousands of servers doesn't prevent you, and in fact, it actually doesn't make it much harder to build something that only runs on 5 servers. And I think what you get if you're a small company, when you're a small company, I think automation is actually even more important than when you're a large company, because your time and your leverage is so high. You don't want to be, if you're a 3-person startup, you don't want to be up in the middle of the night trying to fix one of the 3 Amazon servers that just went down, trying to recover the state that was lost. And if you can rely on some production grade infrastructure from day one, you'll likely be much more productive. Especially if we make it really easy for you to get up and running with this production grade infrastructure.
One of the questions that I think of when you're talking about this is, I'm thinking about the smaller business and what they're thinking about. A lot of them, I think about just using a service like Amazon, right, to to handle all these complexities. And the question that I have is like, okay, so let's say you do that, right? So you go to Amazon, they handle all your complexities, right?
Yeah.
It seems to me where like there's like then the need comes in is like saying like, okay, well now I'm on Amazon. How am I also, we also have parts of we have people who are like really interested in using kind of like the very powerful capabilities that you get on Google Compute Engine, right? Or we have but plus there's all these things over in Azure, right, that we could leverage if we really wanted to, right? That to me seems where it's like the market intersection for you guys. This seems like the opportunity there, because in the meantime, a company could just go to Amazon and say, okay, I'm just gonna use Amazon, right? That's my choice.
Yeah. So a couple of things there. I mean, certainly one of the use cases for our software is the hybrid cloud use case, where you have something on-prem or maybe on one cloud provider, and you want to add capacity on another cloud provider. And a couple of pieces that we are building make that fairly easy. So, for example, we're trying to give you a reference implementation for service discovery, and there are lots of ways to do service discovery. But if you just want to get started, and I mean, we believe ours is, of course, one of the great solutions that are out there. You don't have to worry about building your own. You can just get started right away. Another one of those pieces is, or another reason why you might want to use something like DCOS is that if you just program against the API that Amazon provides you with, you're going to be locked in, and frankly, that maybe some of the tools are not the right tools for you. And if you use Mesos as the base, which is 100% open source software, you're not locked into any specific vendor. You're not locked into our system. You're not locked into anything, and it's kind of an abstraction on top of your IaaS or your bare metal or your virtual machine. You can run a Mesos process inside a virtual machine and start containers within the VM and bin pack the VM, which might sound initially sort of counterintuitive, but it's actually not, because going back to the use case of Airbnb, for example. By the way, Airbnb in terms of scale is about 2 orders of magnitude lower than Twitter's scale. So,
I've used it over the past few days.
Yeah, I mean, and by the way, I mean, that's actually really interesting, right? Like Airbnb, you likely, even if you use it every day, even if you were to stay at a different Airbnb every day, you're likely just going to do one booking a day. And with Twitter, every time you're refreshing your tweet stream, every time Donnie writes a tweet that's delivered to 20,000, 30,000 people, it's the
I wish I was delivered to that many people.
The strain on the infrastructure is just so much higher.
Yeah.
And yeah, I mean, I think for us, preventing vendor lock-in is another big piece of the puzzle.
Big time. So the research that you're seeing in self-healing systems, the research you're seeing kind of in like these very data-centric architectures. What are you seeing out there, for instance, that I don't know if you were at we're probably paying attention to Do Summit or not, but maybe that as a context for an event that happened this week, where you're starting to see some of these shifts, right? You're starting to see things like where containers are being used to kind of break up the complexities, and I think what you say, like decomposing problems into tasks. What are some of the kind of new things that you're seeing that you're excited about?
Is that the question? Is the question for me or for Donnie?
Yeah, for you.
Okay. Yeah. So what I'm excited about is actually some integration that we've recently done with the Hadoop ecosystem called Project Marriott. So the work stems from, in part, from eBay, from us, and we're collaborating with MapR, heavily on that. And what that does is it really brings this entire big data ecosystem that has been developing around Yarn over into our world. And this is another step to break up these silos that exist between the different verticals, right? Where you used to have big data is a silo. It's siloed from stateful services. It's siloed from the past. And now we're trying to bring them all into the same cluster cloud data center. We're trying to break up these silos, and the benefit for the users is that you're going to save massively on infrastructure, because we drive up utilization. Because what usually happens is each of these silos will over provision, and each of these silos has usually a different usage pattern. For example, batch analytics, oftentimes the peak is realized during nighttime, because an analyst runs smaller jobs during the day to validate what they want to get done, and then at the end of the day, they might kick off the large Hadoop job that goes and processes the last 4 months worth of booking data. And so before they leave office, they kick off that job. And so after they leave the office, that's when the batch silo is heavily utilized. And the pass oftentimes, at least at consumer internet companies, realizes the peak somewhere around the lunch hour, where everybody checks the email or everybody checks their Twitter. And so you can easily offset them. And if you were to over provision in silos, you would never offset them. You would just have, I think the number Gartner always cites is about 10% average utilization in today's data centers. And that's largely due to the fact that you're siloing each of these use cases off. And we want to break down these silos, and that's why we saw at companies like HubSpot that are embracing this technology, at Twitter, at Airbnb, we saw a massive increase in utilization after moving towards towards Mesos and now, of course, DCOS.
Donnie, did you follow? You're following the Hadoop Summit this week, and what are some of the things that you're looking for? You're watching the observations that you're making. Florian's talking about the silos and everything else. But is there anything that was standing out to you that kind of has you thinking of about where things are going in the market? I mean, it's a very kind of a abstract way of putting it, but I'm just curious on your thoughts and observations.
Yeah, I mean, the silos is a great point, Flo, because that's been a problem for a long time, especially with big data, where you've got like the data engineers that build the Hadoop cluster, and they're not the same IT as all the other engineers out there. But one of the things that's different line. One of the things that I'm always looking out for with big data as a whole is how I tell whether an ecosystem is maturing is whether people are building normal applications on it. And as those applications get higher and higher level in terms of the tasks they're accomplishing, right? So like, first step is, hey, you can access Hadoop like a database. Great. And then second step is, we've got these like pretty complicated analytics apps, maybe people who are really experts at doing this stuff. And then, so the next step is like standard BI, and like, what's going to be after that, right? It's going to be like normal, not boxed applications, but that kind of idea, right? For data intensive tasks. And so that's the thing that I'm always watching out for these, and it's, in my opinion, not there yet, but it's on its way. I think going back to the silo thing, tools like Marriott are great, right? For being able to, understand and sort of share those workloads across all kinds of different environments, and ideally not have those environments in the first place.
Quick question, actually, from my side for you, Donnie. Do you see do you see that Spark usage is increasing drastically? And is it who do you think is suffering from that?
Who do I think is suffering from having to use Spark, or suffering as a consequence?
No. And like in terms of the vendors, whom does it put pressure on that the Spark usage is increasing heavily? Because we certainly see a lot of interest in Spark in the ecosystem. Yeah, no, it's a great question. Actually, I did a bunch of research back around the time of Strata this spring, so March or February, looking sort of quantitatively across different sources of Spark adoption. And, not surprisingly, what you see is basically Spark just going off the charts compared to basically everything else. Mm-hmm. Over the past, let's say 4 to 5 years, you can see kind of all the different Hadoops and Cassandra and so on getting more popular. And then since basically the beginning of 2014, Spark has just like shot right off the charts, just almost a vertical line in terms of adoption, looking at Stack Overflow, for example. And then, I also compared that to Hacker News, and it's not the same. It's not just exploding, but it's still growing in popularity faster than basically every other tool for working with big data, at the level of popularity it's at right now. And so, it's absolutely, becoming really popular. I think one of the big reasons is Python, but I'm a Python fanboy. And so, take that with a grain of salt as you will. But I think, accessibility is a huge factor in the popularity of these things. Much like I was talking about with the Hadoop ecosystem as a whole,
moving toward business apps, that's, toward apps that are usable by a broader audience and accessible to a broader audience. And I think one of the reasons Spark has gotten popular is exactly the same thing, right? I mean, sure, you've got the in-memory performance, and that's fantastic, but you've also you're reaching a whole new ecosystem with, the addition of the addition of Python for basically data people, and then the addition of Scala for your sort of standard developers, right? All of those are audiences that you couldn't reach easily with Hadoop. And so, the second part of that question, right, who's losing out as a consequence? I think, one of the easiest ways to look at that is, well, who's racing to partner up as quickly as they can? And, the first thing that happened when Spark started getting popular is every Hadoop distribution jumped on the bandwagon and started shipping it, right? Because they were threatened. And if they're able to partner up and maintain that audience base and that customer base, they've, effectively dealt with that threat. But I think, the clear alternative is like, what else are people using for really large data-driven workloads? And thus far, it's been mostly Hadoop.
Interesting, yeah. I mean, I think all of the big Hadoop vendors have really started to embrace Spark as well. So, yeah.
Well, exactly. I mean, you look at the sort of partnerships with Databricks over the past 6 months, and I think probably every single one of them has one at this point.
Yeah.
Even though Databricks as a company is early enough that, I don't run into a lot of people running Databricks Cloud, for example.
Yeah.
It's mostly people running Spark in some other setting. But another interesting kind of fact point around Spark too is, so the Databricks folks shared with me what their users were doing in terms of languages, and 100% of them are using SQL. Every single customer on Databricks Cloud is using SQL. Right? They're using something else. Some, a bunch are using Python, some are using Scala. But, I think SQL is the lingua franca for data searching and analytics, and it's going to be that way for a long time.
Yeah, I personally like SQL a lot. I think it is a great language. I think it's also great if you don't have to compile a bunch of Java before selecting a couple of rows from from your data set.
Well, great.
Yeah,
well,
absolutely.
We're coming up on the 10 o'clock hour. And, I just wanted to maybe conclude things here with, Florian, what's coming next from you guys? I mean, you don't want to like reveal your news, but I'm just curious, like, kind of generally, what are you guys are thinking about looking at on the horizon? Is it the development of these new types of tools? And if so, kind of give us an idea of your thoughts on those tools and the general trends in the market.
Yeah, so for us, what's coming up next is mainly making DCOS even better than it is already. And I really would recommend you give it a spin. I mean, we're extremely excited about the product, and we'll add more features to it. We'll add more components to it, like new frameworks and so forth. But we'll also make the tools around debugging that we talked about earlier, of course, even better than they are today. We'll try to automate certain things, and we just want to make the life of data center operators, of developers, and what we call new framework developers much easier, and really make your data center programmable. The data center is the new form factor, and it needs an operating system. That's what we strongly believe in. So,
Donnie, what if you don't have a data center? I'm just kidding. That was a question I had before. What if you don't have a data center?
Right. Well, lots of colos out there, right?
So when we say the data center, I refer to, like, if you have five servers in the cloud, you have a data center.
Okay, there you go. Essentially, yeah, it's just somewhere else.
Yeah.
Well, good, Donnie. Any last parting thoughts? I'm going to get to see you next week, and we're going to talk to Adrian next week. So we'll actually follow up Florian with this conversation with him. But Donnie, any parting words of wisdom?
Yeah, I mean, the parting thoughts, and something we didn't really have a chance to get into much today, but is looking at the Mesos ecosystem itself. You can see people starting to move up the stack there as well, which I think is a great indicator of health. Before the podcast started, Flo mentioned that Capgemini has this Apollo framework for building microservices on top of Mesos, and Cisco Cloud actually released another one called the Microservices Infrastructure for doing exactly the same thing. So I think that's a great indicator of, growing adoption and a lot of the tooling and support people need to become productive with this versus sort of low level primitives.
Yeah, and I think that kind of brings me back to my question at the top of the show is like this underlying purpose-built infrastructure and what's being done at the network layer, the storage layer, and such. So Florian, we'll have to have you back and talk about that another time.
I'd love to.
Great.
It was awesome talking to both of you. Thank you so much.
Well, you're welcome, Florian. Thank you very much for joining us. Donnie, thanks for being here again. And we'll be back again next week for the new Stack Analyst show. Bye-bye.
Bye-bye.
That's it for this week's show. Thank you very much for joining us. Audio editing and sound design for the new Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you again for the new Stack Analyst podcast. Bye-bye.